In this video, I will show some new Ketcher functionalities that were developed by Ketcher's team and the community on GitHub in 9 months since the last video. I'll do that through drawing modified peptide drugs and using Ketcher version 3.6. Let's start with probably the most famous peptide drug at the moment, semaglutide. I'll add the natural sequence in sequence mode to avoid drawing 30 bonds manually. The second monomer should be 2-amino-isobutyric acid. So I will select this alanine and replace it by choosing AIB from the library. Now I'll go to small molecules mode to draw the fatty acid. Let's switch back to macromolecules mode, snake layout, to finish drawing our structure. I'd like to fit the whole structure into the viewport, so I will change the number of monomers in a line from 20 to 5. All that remains is connecting the fatty acid to the lysine. I'll select the bond tool and connect the R3 of lysine with the carbon on the small molecule. Let's switch to flex layout mode and move on to the next peptide, goserelin. I'd like to show you a new way of adding monomers to the canvas in snake and flex layout modes. In addition to the previous way of clicking on a monomer card in the library and then clicking on canvas, monomers can also be added through drag and drop. Also, you no longer have to switch to snake or sequence layout modes to be able to lay out the polymer properly. Now monomers can be snapped in relation to one another. Before I switch to small molecules to draw the remaining parts of goserelin, I want to highlight some other changes. The monomer library has a slightly different appearance than before, and there is an even more compact version optimized for small windows. Amino acid colors have changed to ones that give more information to chemists. Acidic ones are red, basic ones blue, polar neutral ones pink and purple, and non-polar ones green and yellow. Now back to goserelin. I'm going to the small molecules mode to draw isobutane and aminourea. And back to macromolecules mode to connect them. The last structure for this video is octreotide. It is a cyclic peptide with 8 amino acids, out of whom 3 are modified. But I'll add only one modified monomer for now, because I want to show you an easy way of modifying multiple amino acids. If I select all amino acids and open the context menu via right-click, I see a new option of Modify Amino Acids. Here I see what modifications are available, and on hover, what exact amino acids will be impacted. Tryptophan and one of the phenylalanines should be D-isomers, so I will select them and choose inversion. Now I'll just arrange them and this peptide is done. The last thing that I wanted to highlight are polymer properties. I can select any of the peptides I drew and see the molecular formula, mass, isoelectric point, extinction coefficient for the wavelength of 280 nanometers, amino acid composition, and the hydrophobicity graph. Properties can also be calculated only for part of the structure. And as before, I'll finish by pasting 2 short peptides. Thank you.